All right, welcome everyone. Anyone that cannot hear me? Great, excellent, let's get started. So, this session, I truly believe, if you take the learnings from it, it could actually save your job or even your organization. I've been in cybersecurity and architecture for a long time, and I think everything's good in hindsight, right? This is the hindsight session. Take what you learned today, actually action it. And if you already know what I'm going to present, then try and iterate on it and then share it back with the community through open source projects. So that's my challenge to you all today. I'm going to be going through an introduction to the well-architected framework. Then we're going to move on to the 5 areas of security in the well-architected framework. Now, I've been guilty many times of putting incident response last in every presentation, so now I've got it first, right? So we're going to do incident response first, and it should be front of your mind as well. And then we'll move on through detection and identity and access management and the other areas. So the 3 key links that you need to know for today in this session, you're welcome to take a photo, is the first link is the main homepage for well-architected framework. The second is a web version of all the white papers, and they're frequently updated with little tweaks and updates over the time. We also have a well-architected labs website, which is that one, which is also stored in GitHub, in the well-architected labs GitHub repo. This is being, in the GitHub, it's open source. So it's very simple hands-on labs from introductory through to advanced topics, so you can actually learn hands-on. And if you have any feedback, you can easily do a pull request or submit an issue in GitHub for us. So I really appreciate that feedback. So, I'd like to ask the question, are you well-architected? There's 5 pillars of well-architected. We start off with operational excellence. It's really good to know what your business priorities are and how you operate your workload. And when I say workload, I mean a group of applications that delivers a business value, right? So it might be your ERP system is a workload which compromises of many different applications and suites. Then we move on to the most important pillar, which is security. We move through reliability, performance efficiency, and finally cost optimization. So these are the 5 pillars that make up the well-architected framework. Bit of history. So it started off in 2012. It was just a conversation with our customers that our architects had. It was, are you well architected? I was like, what do you mean by that? Well, let's whiteboard it up. We took all these learnings from working with customers and developed the framework over time. Really proud that we launched our first self-service tool in the AWS console late last year at a reInvent conference. So you can now use the tool to evaluate your architecture. You can evaluate it even in the design phase, all the way through to production, and continue to iterate and improve the best practices that you're following. Also last year and 2017, we released partners. So partners, specialized accredited partners, can go in and do a review with you and help you with the remediation efforts. So the partners, the individuals, are all pro certified and have been on a specialist training, so they can absolutely help you with that. So we think about well-architected to help you build and deploy faster, lower and mitigate risks, and so on. But it's really about delivering the business value. So again, we tie back to operational excellence. What is the value that you're delivering in this particular workload, this suite of applications? The well-architected tool, we're building out multiple regions globally. We recently launched Sydney. If you haven't told my accent, I'd love the Sydney region, lots. You can use it as a learning tool. So even if you use the tool just as learning, you might try out, say, the security pillar, that's fine, as long as you're getting something out of it. It is free to use in the console. So what should you do first? I often get customers that say, okay, Ben, I've done a well-architected review. I've got lots of high-risk issues in security. Like, where do I start? I don't have all the time in the world to go and fix it. So start with identity and access management. So if you are having shared root credentials everywhere, obviously that's something that you want to fix first. So from that, move on to using automation. So I put automation next here because you can use automation to do everything else. Well, technically, you can actually use automation to create the identity and access management things, but using automation. Then moving on to detective controls. So have you turned on guard duty and CloudTrail and all those detective services. Then being prepared for an incident. Yes, I put it last now, but you should actually get identity and access management right first. So these are the 4 critical things in the order in which I recommend you do them. We have a number of design principles for security for well-architected. So starting off with identity and access management and finishing off with being prepared for an incident, that is incident response. Probably one of the most critical ones, besides automation, is keeping people away from data. You don't want administrators or end users or business users to directly gain access to data because people make mistakes and people are going to do something wrong with that data. They could corrupt it, they could delete it, or they could share it outside your organization unintentionally. So it's really critical to keep people away from data. And later on in the session, I'll have some insights on how you can do that. So this is actually a true story. Once I was handed a WordPress site and I was told to secure it. And it was in AWS in a VPC. So what I'm going to do throughout this session is build upon this sample architecture. So you can see I've simply got a single EC2 instance. I've got a custom API backed by Lambda. I'm using EFS for storage for the WordPress site, and I'm using some fundamental services like SNS for notifications and S3 for storage of the content data. So what I'm going to do is build out this throughout, and I'm going to score it. I'm going to rate it based on the questions, the 11 security questions in the well-architected pillar. And these red boxes here represent the critical issues for each of the questions. And you can see I've done a review and I'm completely red. I'm not following any best practices. I have a lot of critical issues that I need to go in and remediate. So let's start off with incident response first. You can use guard duty as a really easy starting point. So guard duty has a number of findings, and these findings automatically get data from the data sources. So the data sources include VPC DNS logs, flow logs, and CloudTrail. You don't actually need to go in and configure these logging sources. Guard duty will do that for you, consume the data, and give you actionable insights. So findings that you can go and action, and you know there's a high probability they're not going to be a false positive. They're going to be real. Bitcoin mining is a big one. It will detect Bitcoin mining based on the DNS logs and the DNS requests and the VPC flow logs. So I'd recommend, if you haven't already tried guard duty, turn it on. There's a free 30-day trial. See how it works for you. But don't just turn it on. Enable alerting. So actually get the alerts that it finds. Otherwise, you're going to have to log into the console and go and consume them. So we've got a new incident response guide that's linked to at the bottom there. Really, really good information and insights that was just released last month. So if you pair up guard duty with its findings, playbooks or runbooks, some people call it as well, add in partners, practice incident response through game days, can be very, very powerful. I've saved a lot of sleep from doing this in the past and helped a number of customers with this over the years. So that'd be my recommendation. Playbooks. So you can think of playbooks as just a rough guidance of what you should do in certain scenarios for incidents, as opposed to a runbook, which is a really rigid, predefined list of actions or for a different scenario. So playbooks is more loose, runbooks is more tight. That's how we define it anyway. Playbook can be really, really simple. So this is a markdown example. It's very basic, it's missing a lot of info, but you get the headings. It's in markdown. So being in markdown means you can store it in your source code repository and version it when your source code changes, when your CloudFormation templates, your infrastructure as code changes. So then you can start to think about hooks. So somebody's changed or added a security group in. Is that security group or security groups referenced by this playbook? And then do I need to go in and update the playbook? Should I fail the build in my code pipeline because somebody hasn't gone and touched the playbook after they've made major changes to the code or the infrastructure? So this is very powerful. I like to store runbooks there instead of in a wiki, because you always forget where you put them in a wiki, even though they have great indexes. Game days, really, really important to practice incident response. Unfortunately, many people just don't have the time. But if you can carve out a few hours, if you're lucky enough to be able to do a full day, say every month, you can pick the guard duty findings that are most relevant for you and your workload and run through them. Create a little run book or playbook and then just practice them. And practice them openly in the team. As you mature that over time, you can think about going to, if you're large enough, going to a full red team, blue team, or doing it unscheduled. So having a finding pop up in guard duty or whatever you might be using instead of, and then how the team responds to that. And the other team doesn't know that somebody is actually doing that. So you can then continuously evolve that over time. More importantly, have fun. So make it a fun event. The first one, you might have a little prize for who creates the best run book or who finds the threat in the shortest amount of time. So make it a bit of a game, make it fun, and everyone will enjoy it a lot more. Right, so we're going to build incident response in an architecture diagram. It's going to be a bit tricky, but we've got guard duty on as our detective control. We've then got incident response playbooks. We don't need them all. We can just iterate, start with a couple that are most likely for our scenarios. Then we're going to have tooling. So we can talk to the number of partners out there in the solution hall, or we can look online. There's many open source toolkits that can help you with incident response on AWS and the applications that you use. Also, if you look in our labs, and I'll be demoing it shortly, we've got some guidance in there as well. Pre-provisioned access is a big thing for incident response. If you have a security team or individuals that look after security, do they already have access, even if it's only read-only, into all your accounts? If you rang them up, can they immediately respond to something? Or do you have to go in and grant them access? And that can be very tricky in certain circumstances. So being prepared and practicing and having that pre-provisioned access and those tools that are ready to go is critical. It's all about hindsight, right? If you had this all in hindsight, you'd be a lot better off. So now the final question of well-architected, number 11, is actually an incident response. Now I've gone through and I've scored myself, rated myself, and I don't have any critical issues now that I've done these things. So let's go to a demo. Excellent. So this is the well-architected labs website, and links to the GitHub repo at the top there. So if I scroll down, so we've got leveling, level 100, 200, 300, level 300 incident response. So this is going to give me some sample commands to use. Apologies, I'm scrolling fast. That I can use with the console or the CLI. And what we've got so far is using CloudWatch logs and VPC flow logs. So what I'm going to do, I can look at IAM access denied attempts, who's trying to get access to what inside my account. I can simply copy and paste this into CloudWatch logs events console. Let's just run this here. Yes, it is one I prepared earlier. So you can see here, this gives me a list of all the users and roles that have been recently created, and I'll just set my I've set it customized to 2 days relative here. So I can see Sean Mackie D's being created, and an adversary has been created. Okay, it's a demo, right? They're not always going to be call themselves adversary. And I've got a role called AWS role hiding. So as you know, a lot of AWS built-in roles start with AWS. So what better place to hide a role than calling it something starting with AWS? So you need to be aware of that and actually know what's going on inside. And that goes back to our design principles of using automation. So using automation to work out what is going on in your accounts, in your environment. So I've got the user ARN, and I've got the source IP addresses that were used and the time. So if I cheat now, go to another one I prepared earlier, I can plug in an access key in this field. So we're filtering the CloudWatch log group for CloudTrail using an access key ID of that. And now I've got my different events that this has created. So it's actually created a bucket. And if we drill down, the created bucket is called ha ha ha, you will never find me. So you can see if you have these different pre-canned like scenarios, and of course you can automate this, you can go in and find a lot of insights in your workload. Screen resolution. And from VPC flow logs, I can then find access denied attempts. And a good one to look for in VPC flow logs is, has something inside the VPC tried to get to something else inside the VPC and been denied. So that could be an application server trying to access a database and it doesn't have the correct permission or security group to allow that. So that could be an indicator that an adversary has got hold of say it's an EC2 instance and is trying to get to a different database or trying to do recon within that environment and try and find out what's going on. Right, identity and access management. So I'm not going to go through all the inner workings of identity and access management. We've got some really awesome sessions this week, and they'll be up on YouTube, of course, for all you watching at home. But what I am going to say is just some tips that you should look at. So I've worked with lots of large customers with like hundreds of AWS accounts, even thousands. And using federation with traditional methods can get quite tricky. There's a little trick that we had in a blog post a couple of years ago, and the link's down the bottom, is using, this scenario is Active Directory. So you can actually use parameters on the individual user and then restrict based on those parameters in the user custom. So you see here, we've got the user URL. So we're using the URL field, which is built into Active Directory, and we can build out a comma separate value list of the accounts. And you can use wildcards in this as well. So you can have user, or this could be on a group level of Active Directory, and then do *dev. So if it's in the list of dev accounts, *dev, then they're granted access to it. So do check out the blog post. There's a lot more information on how to do that. Also, if you're not using federation and want to find out more, especially single sign-on is a really awesome new service, go and check out the federation link down the bottom. There's a whole page dedicated to federation on that. Permission boundaries. Who's using permission boundaries already? Not many? Okay. So permission boundaries is a fairly new feature. One of my favorite features that's come out recently. It allows you to create an administrator, so you can have, say, a role that is allowed to delegate permission for another role, right? So the scenario, I'll just build this out here. So the scenario is, I'm an administrator and I want my development team to run their own Lambda functions, create them, but with that they need to be able to create roles and manage policies in identity and access management. And before permission boundaries, that was a little tricky. Whereas now, I can give them a role that they can use, and they can go off and create their own permissions, their own roles, their own policies. They can do anything in those policies, but they must have a permission boundary attached. If that permission boundary is not attached, they're not allowed to create the role. And of course, that permission boundary then contains what that role can do based on that policy. So I've then now bounded the role, and I've now allowed my developers to go off and do things freely, not constrain them. And I don't have to pre-provision all the roles and manage policies for them. So an incredibly powerful, awesome new feature. Automation. So you're going to hear me talk a lot about automation. What should you do with automation and identity and access management? It can be a bit tricky. So if you've turned on federation and you were using users and groups built in, go and clean up all those users and groups. You probably don't need them anymore. You should also go and audit, preferably using a tool that we've got that is in the labs, that goes and does a daily report, emails you a daily report of the unused users and unused access keys. And you set the date stamp, say 90 days, and it will go and give you this report so you can go in manually or automatically go and disable those users or the access keys. And of course, the best practice would be to use federation, and using federation with the security token service or STS, and not use access keys at all. You also can remove the people that have left the organization. So whether they're on long service leave or they've left, if you can tie this in with your HR system, with your identity and access management system, you can automate those people being removed. And of course, people might leave abruptly your organization, so you really want to get in there quick and disable their access. If you had lots of different accounts with different IAM users, that can be very difficult to do. So you want to centralize that and really automate it all. And of course, constantly reduce permissions. So you can use Access Advisor in the IAM console to go in and have a look. And you'll see a list of the permissions that user or role or group has. And then you can limit and lock down over time. So you want to get that least privileged access in there. A common pattern I see with customers is, and a common question is, can a role assume another role? Well, yes. So in this scenario, I've got a Lambda function which has to have a role attached so it can do things. In this case, we're going to use the Lambda function to assume another role in a different account. And then in the same Lambda function, we're going to go and do something. In this case, it's signing an S3 URL. And that's the code for it. So we've actually got a lab coming soon for this. So if you check back on the labs page, we'll give you a bit of a how-to, besides trying to type in this manually from this slide deck. So if we go through now, we've got a single instance can now have a role attached to the instance. So that's going to automatically get credentials. I don't need to hard code anything, don't need any access keys on it. It will automatically get the credentials for that particular role that's attached. We're using organizations to centrally manage multiple accounts and apply service control policies in the organization. So if we had a development account, we can restrict exactly what that development account can do and in what region and who can access it. So we can get really, really granular with new resource-based SCPs now. Of course, we're using identity and access management, the best practices that I've mentioned. We can use single sign-on. And one of the best practices in well-architected is enforcing MFA. So don't just enable MFA, but enforce it. If you're using federation, this enforcement must be in your federation provider. Don't allow people to log in unless they've got an MFA token or a YubiKey or some other way. And of course, I'm sure you've all read the news. You've got to be very wary of SMS-based multi-factor authentication, because there's a number of limitations in it, shall we say. For using built-in IAM users and groups to force MFA, you can only allow that user to assume a list of roles. And in those roles, you set the trust policy that it must have MFA in that session assumption. So then the only way that that user can do anything is to assume a role with the MFA. So you can significantly improve the security using inbuilt users that way. Secrets Manager is a fairly new service as well. Secrets Manager, in the demo further on, integrates with KMS for storing the secrets, as well as Relational Database Service, RDS, and more. And I've got that in the demo coming up. So it means that if we do need long-lived credentials, like a database password for Aurora or MySQL or something like that, it means we can safely store that in Secrets Manager and automate the rotation. And nobody needs to store it, nobody needs to put it on in any code anywhere. So now I've gone through the scoring, and the first 3 questions are on identity and access management, and I now have no critical issues in that. I've also turned on a number of management tools just for good luck. So we're using CloudFormation, so we can build everything in CloudFormation, infrastructure as code. Using Systems Manager, so Systems Manager is going to help manage the EC2 instance. It's also going to replace SSH. So I don't need SSH on this at all. I can automate everything through Systems Manager, and adhere to my design principle, keeping people away from data and the system. Using the AWS code services, I can also store all the infrastructure and the code in the different services. Of course, you don't have to use the AWS code services. You can use your own open source or partner-based tools, whatever you like, as long as you're meeting the requirement of using the automation and the tools. And CloudWatch with CloudWatch events can help you do a lot of the response as well, and I'll show that shortly. Detective controls. Here's automation again. We can use CloudFormation to turn on all the detective controls for us. And I know a lot of customers that do this as the baseline for when they create a new AWS account. And there's a lot of new features coming in different services that are going to help you out with this as well. So starting off with CloudFormation. By the way, how to do this and the example code, the CloudFormation template, is all on the lab link that's down the bottom, which is off the main lab page. So we're going to configure CloudTrail. We should also additionally configure alerts. So what highly privileged API actions do I want to know about? What is interesting for me? We're also going to configure guard duty. So guard duty is a simple tick box turn on, but with this CloudFormation template, we're also going to enable email alerting. So we're going to get an email of the alerts. It's not a pretty email, but it's a start. Then we're going to enable config. So config service will store the history of the configuration of the particular items versus CloudTrail, where it will store the API requests and all the details surrounding that particular action. Additionally, we want to think about config rules. So config rules can determine the state of a particular resource. Is that EBS volume encrypted? No. Okay, that goes against the EBS encryption rule that I've got, and I need to take an action on that. Taking that action, we can now do through the new auto remediate feature of config rules, which is linked to there down the bottom. Also, if you're wanting to build your own rules, there's a new rules development kit as well, also on the link up there. So I've mentioned email for alerts a lot. Email is actually really bad because how are you securing your email system? You know, who administers that? Is it outsourced? Do you trust your entire business on your email system? Probably not. So the key is to get visibility really, really quickly. I know I read my emails like once a day. That's all I do. But if you had a messaging system, so whatever your favorite chat app is, if you had those insights from guard duty and CloudTrail and config rules coming straight through and your whole team worked on that all day, every day, then they're going to take immediate action and everyone gets visibility. You can @Ben, I'm working on this now. Or don't worry, that was me. Oops, sorry. And you can get immediate insight rather than seeing the email the next day and oh no. I've got a customer that uses chatbots to do everything. So they never log on to their accounts, AWS accounts. They use chatbots, which they maintain through a code pipeline, and they do all their changes through chatbots. So I'm not saying that's the right thing to do. It's just one example of a customer doing it, and they've got a lot out of it. Also paging. So how are you going to escalate these alerts into a paging system? What if it is actually midnight or 3 a.m. and somebody needs to take action? And of course, there's many partners that integrate with these different services that can automate the paging and automate the escalation of the pages. Who has done a threat model before? Awesome, excellent, great. Threat modeling is really important because you need to know what your threats are. You need to know what to look out for. So every threat has a mum. So a method, opportunity, and a motive. When creating your threat model, and I'm not going to go into any more detail, you need to circle back, work out based on your different threats, have you got the appropriate detective and preventative controls in place, and continue that circle once you've created the threat model. What should you look for? So being prepared. So actually setting thresholds on different alerts, not just enabling the logging and monitoring and alerting, but actually setting thresholds using automation. So that's using automation to respond and automation to investigate. Can you have something that automatically investigates a DDoS attack and mitigates a different, say, a certain user agent or IP address that is doing a DDoS attack against you? Yes, you can, and I've got a solution that I'm going to show you for that later. And diving deep. Very important that you're being prepared, you have the tools available, you've practiced them, that you can dive deep on. Insiders. So insiders can be both intentional or unintentional. So I could accidentally do something and cause the same consequence as somebody maliciously doing something wrong. So things to look out for when detecting an insider is, have you actually lost any visibility? So have you actually lost any logging or monitoring or metrics? Has somebody just modified the dashboard accidentally and then something happens, something bad happens? So you got to be aware of that. Transfer of data. So it might be a team, an individual's laptop, or that individual themselves. How much data are they transferring out? Are they transferring out your customer database or all your secrets? So you need to have those controls in place to be able to detect that. Unused resources. So if you have especially a contractor that contract may be expiring, maybe they're not that happy, have they actually planted something somewhere? And it's not necessarily in AWS. Have they planted something somewhere that they can go back, like a back door, either in the code or in the infrastructure? So have a think about that as well. And how do you detect that? You need to know exactly what you've created, right? Going back to CloudFormation, you can do a diff on what's in the CloudFormation and using the tags and what has been created manually. So knowing that manual versus automated creation. And of course the social aspects. Has that person over in the corner there been, disconnected and disgruntled and sick every day? Reconnaissance is really important to look out for. So DNS reconnaissance, GuardDuty will look at the VPC level of DNS flow, DNS logs within your VPC. If you're using Route 53 for DNS, then you can enable logging and get the insights from those query logs. So then you can start to detect different patterns. Has certain countries doing queries of unknown or non-resolvable addresses? So you might have admin dot. How many people are requesting admin dot of your domain? And that is a sign of people doing reconnaissance. Then you can tie it back, the country, the ASN, like what the service provider is it a VPN provider that's doing that? Then you can then cross-reference those logs and those requests with other systems. I had a customer that did it with their badging system and their call center. So they found there was a particular country that was doing recon on them, and that particular country was regularly calling their call center. They brought back the call center call logs, and they were trying social engineering attacks. So they've got these multifaceted attacks that are going on. So it's incredibly important to get that whole big picture of what's going on, not just the AWS environment, but wider than that. So who thinks they're ready to detect a credential stuffing attack today? I think I saw 1, 2, 3. Yeah. It's really difficult because this is an example CloudFront log. This could be a credential stuffing attack. You don't know. Firstly, they're using an IPv6 address, so it can be hard to pin down. And they could be millions of addresses in this single service provider, so even using that method can be hard. Also, it's a legitimate request. So you can see it's a 200, which is a OK response, HTTP, and it's to the login page. So you don't know if the request has succeeded at the application level or if it has not, because this is just the CloudFront log. But if you're going just on this, it's not enough. So what else can you do? We can build an application level metric that can detect the login success and report it over time. So normally login success is over 90%, and then one day, past midnight or towards midnight, that login success starts to drop off. They're all legitimate requests to the login page, but they're using a password tool that uses known passwords, and they're guessing an account ID, or maybe they're actually a proper customer and they're using a customer account ID. They're going through and they're trying that password database until they actually get a correct password with a correct username. And the ramifications can be quite large. So this is a really good example of how you can detect a credential stuffing attack. It's not the only one, it's just a good example. So at the application layer, I want to really challenge you and what you do to put in place. So having a captive portal, and there's many out there, can help. Using browser-based fingerprints can help, but a lot have circumvented that, so they're very limited. Using multi-factor authentication. So a number of financial institutions out there allow for MFA. Many do not enforce MFA, right? So you can only do a transaction if that session that you've logged in as for your internet banking has multi-factor authentication turned on. And of course, SMS authentication is not good enough for that. So I really challenge you to think about how you can improve the security of your application. And this, of course, can apply to the administration side of things, so the AWS console itself. Partners. So I know there's a few partners that are presenting and they're outside in the hall that can detect this and detect bad bots and all those bad things out there. And they can do it a lot better than you and I can. So do go and check out those partners. There's also Troy Hunt, created many years ago, Have I Been Pwned? So he gets knowledge of these different password dumps and allows them to be indexable and has an API. So you could actually go and use the API and check if those passwords that your users are using have actually been in a password dump. Are your users using the same password from something else, from social media or something, and that has been compromised in the past? So there is another way of doing that. And there's over 500,000 index passwords in there, 500,000 unique passwords that are in that. And they're not just password 123. So you want to continuously evaluate what you're doing. You can use the CIS benchmark, and there's a really good quick start on this. So the CIS benchmark does tie in with some of the best practices in well architected, and you can go and deploy these config rules quite easily, and then simply see the non-compliant resources. User must not have associated policies. Okay, user must have MFA enabled. I've got one non-compliant user that doesn't have MFA enabled. I can then customize the remediation action, go and email that user, go and disable that user from logging into the console, or limit the scope of their policy. So it's really, really powerful, and the CIS one is a really good way of getting started with the config rules. So what have we got on now? We've got VPC flow logs on, so for good detection, GuardDuty, CloudTrail, config, and CloudWatch. So we've enabled all that using that detective controls template, and of course we can add on partners to enrich in that. And we've thought about our threat model as well and how that ties in with all of this. So we score, getting a bit more green. We're getting those critical issues ticked off as we go along. So let's move on to infrastructure protection now. And this is going to be a big section. So last year at reInvent, we launched a transit gateway as a new feature for the VPC. Xero, one of our customers, presented example architecture on using a single VPC for ingress services, so they can put in their security services in a single VPC and scale it across hundreds of accounts. So you can centralize the web application firewall they're using in the VPC, VPN, and a software-defined WAN. So you can do that all in a centralized account and use the transit gateway to share it across multiple different accounts. That means those other accounts, those other VPCs, don't actually need to handle the traffic directly. They only allow traffic from this security ingress VPC. On the way out, on the right-hand side, we also want to be wary of data loss and what's going on. So we can put in URL filtering, proxying, data loss prevention techniques in an egress VPC and change all the routes of the other VPCs to only route to the internet through that one. And Transit Gateway is the glue that allows this. I love it. It's not for everyone. If you're running hundreds of VPCs and accounts, even thousands, this may be the solution for you. VPC sharing. Is anyone using VPC sharing? Couple? Awesome, great. So it's really powerful, but it has particular use cases. So if you had multiple different teams that you wanted to share a VPC, that's where it really plays in, and it's really, really powerful for. So you set an owner of the VPC, and they do their things to set up the VPC. Then you can share subnets. And of course, you want to share more than one subnet because you want to run across multiple availability zones. You can share those subnets with a different application team or a different owner. So then you start to get the segregation between the identity and who owns the account and the VPC and the actual VPC itself. You can do this across account, but it must be within the same AWS organization. So it's one thing to think about. Automating protection. So this is a solution that's available on the link down the bottom that you can build out. It's all built using CloudFormation, of course. We start off, we've got the web application firewall. We're enabling logging. So WAF supports logging using Kinesis Firehose, and we've also got logging in CloudFront and the application load balancer. We're then going to analyze those logs using Athena and Lambda. Taking those logs, we can detect HTTP flood attacks, right? And this can be either in CloudFront or application load balancer, and automatically block those IPs that are conducting those flood attacks. We can also detect the scanners and probes, so those bad bots that go out there and try and do bad things, and we can customize that. And of course, this is an example, so you can go off and modify it to suit your requirements as well. We're also doing CloudWatch events to trigger a Lambda to go and download the latest IP reputation lists. And we can then update the IP blacklist rules to automatically block those bad IP addresses from those open source reputation lists, or plug in your own reputation list there as well. And finally, API gateway can be configured with a hidden URL on the page or pages. So a normal browser, when you're browsing the website, won't find this URL, but a bot will. And this URL hooks into a Lambda function that automatically blocks that bad bot. So they won't know. A little trick I've used in the past, it stuffs around with search engine optimization, but it's really good for security. In CloudFront, you can customize the HTTP response. So instead of somebody does a page request and they get a 404, like can't be found. Instead of giving them a 404, give them a 200 with a custom sorry page. And the bots will find they'll get a 200 and they'll just keep trying. They'll keep trying and they'll keep trying and they'll keep trying. It's no badness for you because you've got the cache sorry page in CloudFront and it doesn't even hit your application layer. And the bots then have to do either get really smart or do manual intervention to try and work out and do reconnaissance on your application. So it's a little trick I've learned. Tooling. What tools can we use for infrastructure protection? There's many. I want to cover some of the not so known ones and not so known areas like source code and dependency checking. So OWASP, Open Web Application Security Project, has a number of awesome projects out there and source code. Their dependency check tool. So if you're using open source tools like Jenkins for your code build pipelines, it can plug in with Jenkins and detect those security issues that have been found at the code layer. NPM's Node Package Manager now supports auditing and automated fixing on the command line. So it's really powerful to go in there. Just an example, using Node. Retire.js has similar functionality. Who's fuzzing? Anyone fuzz? Yep, excellent. So fuzzing is, of course, the ability to go in and try different things in an application. So if you take a scenario of you get a web form, will that web form accept malform requests? Will it accept XML or HTML in the username field? Will it accept SQL injection or type attacks in this part? So it's about trying to break an application by using malform requests, essentially, at the network or application layer. Number of different fuzzing tools. So the American Fuzzy Lock is actually a fuzzing tool that other security tools use, right? So they've actually got a trophy case on their website on other security tools that they've discovered vulnerabilities with using the American fuzzy lock. So I thought that was pretty cool. It can be quite complex, but I encourage you all to at least look at fuzzing and how you can help improve the security using that in your applications. There's also Z, which is the OWASP project again, Z Attack Proxy. This is a Windows application. It's really easy to install and get started. Has a really good spider. So it goes in and it will just spider out an entire website. And you can set the depth and all that, customize it. It can also automatically go and try SQL injection for you as well. It's completely open source, but it's extensible through an API. So you can actually go in, plug this into your code pipeline, and automate this into your build. So if somebody checks in code, a CloudFormation template, you can automate the detection and do the diff on the last scan to the current scan. So it's really, really powerful. And there's many different open source and partner products that can do this. I just thought it was a good example to get started early. So let's build out this architecture now. So we've got Route 53. We've turned on logging, of course, in Route 53. We've got CloudFront, which hooks in with a web application firewall. So I've now got a perimeter of threat protection at the edge. So I don't need to scale out my application in the VPC. This is all handled at the edge. I've turned on the automated solution for detecting the bad bots and that as well. We're then going to chop up the VPC now. It's going to get a bit complicated, so you got to bear with me. We're going to have a load balancer tier in a separate subnet layer. So only the load balancers are in that subnet. This has its own route table and its own network ACL. This is why we put the load balancers in there, because this is the only layer that should be accepting traffic from the internet. And the NACL reflects that. That is a network access control list at the subnet layer. The next layer down is the shared services layer. This is where we have our NAT gateways. So the NAT gateway will only allow outbound traffic. We use it for updates to the instances, because we're running WordPress, we need to update it. We need to update all the libraries and that on there as well. And we do that through the NAT gateway. What this means is these instances, which now run in an application layer, don't need direct access to the internet. They get the internet through the NAT gateway. And of course, we could replace this if we had multiple VPCs, multiple accounts with the transit gateway. So we can plug the transit gateway solution in here that I showed before. It also means we can easily turn off the routing at the application layer to the internet. So if I was doing my updates in code, like if I was pre-building an Amazon machine image, pre-patching WordPress, doing all that stuff, I could actually build that, plug it into the application layer, and it doesn't need any internet access at all. It also means I can get really granular on the network ACLs, and I have done in this example. So of course we've now auto-scaling it, so we've got reliability and performance best practices in here as well. So we're auto-scaling, we've got a customized machine image, and we're using VPC endpoints. So the application doesn't need a route outside to the internet to get to S3, to get to Secrets Manager, to get to KMS. And we're also using a database tier. So we're using Amazon Aurora, and we access Amazon Aurora through endpoints at the database layer. Right, so you can see we've got those 4 separate tiers now, and each has their own network ACL and route table, so we can get really, really granular on what they can access. And we can easily lock down and tie down, and of course replace. So if we had this as a template, we can then repeat this solution for many different applications, and the CloudFormation template could be customizable through the use of parameters, and we can go from there. We also should use Amazon Inspector or a partner tool that does similar, so we can detect for vulnerabilities, CVEs, using Amazon Inspector. We can automate that, and using Security Hub as well to getting that high top layer visibility of what's going on inside. You can see now I'm getting more green. I'm getting away from all these high risk critical issues inside this application. If only there was some example CloudFormation template that did the VPC layer and the EC2 layer for me. There it is. There's not every single best practice built into that, just because it would take a lot of customization just for WordPress. We want to make it relevant for many different applications. For example, WordPress stores its password in a file. So in this example, we're actually using WordPress and we're using Secrets Manager on the command line to grab the password from Secret Manager API directly and plug that into the file. So of course, storing a password in a file is not a best practice. However, that's the constraint that we need to deal with for this example. Data protection. Keeping people away from data. How do you do it? Well, in the first case, do you actually need to store the data? Do you need that healthcare data from your customers from 20 years ago? Maybe, maybe not. Do you actually need to store it in the first place? Then, do you need to grant anyone access to that permission? Maybe you have archives of data. Do you need to grant access to those archives from many years ago? You might not need to. So start thinking about how you can either eliminate the data completely or reduce the access to it. Then encrypting, masking, tokenization comes into it, and also isolation. So let's drill down to that a bit. We can use different AWS accounts within my organization to store different levels of data. So if I've got a health workload, maybe HIPAA compliant, PCI workload, I don't want to have them in the same account because they're at different levels of data classification for different users. So I can store them in different AWS accounts. So that's a really good way of isolating it. Then I get the best value of my roles and my role-based access control on that. Also, what I can think about is what I like to call a data bunker. So if you have your most critical data, maybe it's your CloudTrail logs, maybe it's other snapshots of your data, and you're at a point where you may be paranoid about who's operating in your environment, and this may not be for everyone, but you could actually create an account outside of your organization. And that account outside of your organization is never touched. That gets a one-way copy of your critical data. Maybe your CloudTrail logs, maybe it's shared snapshots and other S3 data. You can't touch that. Nobody ever logs into it. Nobody has credentials on that, maybe. So it's one pattern that I've seen some customers do where it does meet the requirements, but it may not be for everyone. Different tooling. So if we're building infrastructure using CloudFormation, suddenly everyone that's building the infrastructure doesn't need access to the console. Maybe you give them read-only access to be able to check and see what they've done and visualize it, but they don't need that direct access. They just need to commit the code, and then the code pipeline will go and do the actual build and testing for us. And we've actually got a workshop this week on how to do this, and there's lots of great examples on different links on the AWS websites. Systems Manager as well. So the example code that I showed before for WordPress, that example doesn't have SSH enabled. So there's no SSH, there's no security group allowing SSH. You do it all through Systems Manager. We do that because we can get fine-grained access to what commands we're doing. SSH, if once I allow SSH, you've allowed any command. They've got root, they can do anything on that instance. With Systems Manager, we can control the documents individually that are run, and we can predefine those documents, we can create them in CloudFormation, and we can get that really granular control over that. And as I mentioned before, a lot of operations as code, so CloudFormation there, using partner tools. The idea is you want a developer or an administrator to commit code, whether it's application or infrastructure, and of course, all the detection, all the remediation can all be code. You want it version controlled in source code repository, and you want it all automatically delivered out wider. Data exfiltration. It started off back in the good old days. It was only host-based. So you'd have an agent that runs on your servers, and it would detect if somebody's trying to copy data out. It could have also been watermarked on your documents. So a PDF watermarking maybe, and you can detect that watermark as it goes through your email server because somebody's emailed that out. Now we've got software as a service providers. What access are you giving to your data and to your AWS environment to your software as a service providers? Do you trust them? What's their policies? Have you done your due diligence? So just be aware of that. Different partners that you would cooperate with. It may be external entities that you outsource to and what they have access to. And applying all these principles that we've gone through today to those partners. DNS. DNS is actually, there's a lot of attacks that can actually exfiltrate data through DNS requests using text records that are very common out there. So how do you actually detect the exfiltration of data through DNS? GuardDuty can help you with that. But again, it goes back to your threat model. Are you looking at advanced persistent threats? Are you going to be looking at state actors? Do you need to protect against them? And how do you test them? Now that you know there is DNS exfiltration, you can use your internet search engine of your favorite and go and find what the different attack vectors are and how you mitigate against that. And you'll find those isolation techniques that I had before will definitely help you with that. Logging. So you can log anything in any log you want. If you had a developer that accidentally or maliciously enabled a Lambda to log something they shouldn't, maybe it is dealing with healthcare data and it has the decryption keys, it could actually log into a CloudWatch log or some other logging system. That actually might be sensitive data that it's logging. So be really, really careful and go in and check what data you're logging. And again, you can use CloudWatch events and other tools to go in and check what you're actually logging. Look for a payment card ID hash or a social security number hash in your logs. So I'd really recommend you do that. Automating data leaks or detection of data leaks. So first you need to know where is your data stored. What services are you using for logs? It's not just about S3 anymore. So there's many different AWS services. You might be using a software as a service partner as well. Where is your data stored and what is being stored? How are you categorizing it? With AWS, you can use CloudTrail and look at interesting API calls. So a really interesting API call for S3 is pre-signed URLs. So you can generate these URLs, and anyone who has that URL can get to that object. That is an incredibly powerful API action that you should be very aware of. So if we wind back to our chat history, if I have that in a chat that goes to the team that's responsible, they can act on it and they know that they've created that signed URL. They know that the application has created that signed URL. They know what's going on. Send it to an email, it will go in somebody's inbox and get forgotten about. So it's really important to know what's going on and be aware of those interesting API calls. And it's also the splitting up from what the normal is. Maybe there's a particular user agent or IP or even a VPC that accesses S3, and you can get that all through the logs. Speaking of S3 access logs, we can actually customize the log information that goes into S3. So here I've got an example cut down of an S3 access log to my example bucket, my puppy photo. I can put a query string. So I'm using code, so X dash, it has to start with X dash, and the code here and an example. So I can treat this like a key value pair. I don't want to store sensitive data here, but I could actually have a code for a data classification level. So I won't say data classification equals top secret here, because I don't want everyone to point to the top secret stuff. I could have code equals, and it could be a project ID or some sort of code mapping that you've got. This also goes into the access logs for S3. So then I can go through the access logs using a tool and find out who hasn't supplied that. Where was that from? And then I can get a good map of who's doing what and where from when, and who's supplying these required or optional parameters on the request. Little tip, the CloudTrail that logs the S3 events does not log access denied attempts. Well, certainly not last time I checked. So if you want access denied attempts, you have to enable the S3 logs in the S3 service itself, pointing to another S3 bucket. Okay, this is my new favorite feature. I take back the permission boundary one. Sorry, Bridget. EBS encryption by default using a predefined KMS encryption key. This is very, very new out, and it is awesome. So I do need to go and update the lab that we have for the WordPress example, but it's really, really powerful. And of course, there is no additional cost or overhead with encrypting the EBS volumes, except for the cost of the encryption key. Really, really powerful feature. And of course, DynamoDB is also encrypted by default now, and you can go in and supply or specify the KMS key that you want to use for that. The encryption SDK is available in the documents. We have a good example down there on how to cache encryption keys. And we can also add an encryption context. So this encryption context will, when I supply the encryption context when I'm doing an encryption operation, I then need to supply that same context, which is a key value pair, doing the decrypt. So this is all clear text and logs and that, but it's an additional level that I can put on it. Right, so let's build it out. So we've got Certificate Manager on CloudFront, Application Load Balancer. We've got our DLP, optional DLP if we need it. And then we're encrypting our volumes for the instances and for Aurora. And now, I'm all green. I have no critical issues anymore. So I encourage you all to take action. So go and play with the well-architected tool. It's free, it's in the console. Even if you just do the security pillar, use it as a tool, use it in the design phase. So when you're first whiteboarding that application idea, have them in your head, go through it, and then continue to iterate as you go along. And the final links, which you all know, do check out the solutions page. Some really, really great solutions up there that tell you how to build things. And thank you, everyone.